This video will cover writing and balancing chemical equations. Please read the OER textbook chapter section 7.1 for more detail. The online homework that associated with this video is online homework 7.1. So pretty much in the previous videos that we learned throughout the term is the fundamental concept that lead us to understanding the chemical reactions. So we're looking at atoms, we're looking at the trend of the periodic table, how electron is sharing or losing or gaining electron right between each of those atoms in the on the periodic table. We also look at chemical formula and how to determine those. Now we're going to put all of those together in chemical reaction. We are going to learn about how to write the proper chemical equation. And then the next video, we are going to look at the reaction stoichiometry. And the last video of this chapter will cover the limiting reactant and the theoretical yield and also percent yield as well. So in this video, we are going to focus on this first. Okay, so this part right here. So let's take a look at 7.1, how to write the chemical equations. So pretty much chemical equation will contain the reactant that would be written on the left-hand side. The arrow represent that these two, when they react, right? So the plus side is represent they add together or they reacting with each other, right? So the arrow will tell us that it's leading to what? It's going to leading to the product. Okay, so the product will be written on the right hand side. Okay, so you need to be able to understand this. Reactant would be on the left hand side, product would be on the right hand side, separated by the arrow. And you also need to include the physical state of each of those molecules as well, because we need to know, right? If you are going to conduct the experiment, we need to know what type of chemical compound we need to obtain, right? Whether it's solid, liquid, or gas, right? So that means in parentheses G represent the gaseous state. If it's parentheses L, that would be liquid, right? So G would be gas, L would be liquid, and S would be solid. And another type of reaction that you are going to also learn about is in the aqueous solution, which is going to be in the solution where it's the homogeneous mixture between the molecule and water, right? So that would be the aqueous solution. Okay, so those are the four states that you are going to see. Okay, so they are different. So in this case, what we are considering is going to be these two in gaseous state combined is going to produce these two, right? So pretty much it's the methane react with oxygen, produce carbon dioxide and water. Okay, so in order to show these properly, you need to follow the law of conservation of matter, right? Because everything when you input, the output have to be equal, it have to be the same, right? So in terms of mass, they have to be the same. So if you're looking at this chemical equation, you will see that the mass of the reactant, if you obtain the mass of carbon, okay, add together with the hydrogen, right, within that molecule right there, and then you add together with the oxygen, two of them, right, you will see that the total mass of the reactant right now is going to be in AMU, right? Because we're talking about the atomic mass. Okay, so we talk about each molecule right now. So if you're looking at the mass of the product on the other hand, right? So on this side right here, you add all of those mass together, you are going to have 1 carbon, okay, 3 oxygen. Okay, so where's the 3 oxygen come from? It's come from these 2 and 1 more right here, and then 2 hydrogen come from there. Add together is equal to 62.024 AMU. So this is not possible because this is going to go against the law of the conservation of mass, right? Because you can't input something less and expecting to be more, right? Because it's impossible. Okay, so that means in this case, there's something that we need to do to this chemical equation, and that is to write the correct chemical equation by making sure that both sides of the equation are balanced. Okay, so what do we mean by both sides? Both sides mean you are going to consider reactant as one part, okay, separate by the arrow, and it's need to equal to the product part. Okay, so that's what we are looking at. Okay, so pretty much the number of the reactant mass will need to be equal to the product mass. So these two mass must be equal in order to follow the law of conservation of mass. Okay, Because mass come from the type of each of those, right? So as long as the number and the type of the reactant atoms, right? As long as the number and the type of these are equal on both sides, eventually the mass of these two sides between reactant and product will come out equal eventually. So that means our goal is in this chapter is to learn how to making sure that the number of atoms and the type on both reactant side and the product are equal. Okay, so what can we do about that? Okay, so pretty much I'm going to consider the same chemical equation right now. Okay, so it's the combustion between methane and oxygen. Okay, so what do we do? Well, first you will need to start to count the number of each element, right? So carbon, there's one carbon on this side. There's also one carbon on this side too. Okay, next, there are 4 hydrogen on this side. There are only 2 hydrogen on this side. Don't do anything yet. Let's keep going. Okay, so 2 oxygen on this side and we have 3 oxygen on this side. Okay, so what should we do then? Okay, so what I'm going to start is we probably notice that oxygen appear on both sides of equation, right? Same thing for all of these. However, if you're looking at oxygen for the reactant side is appear in only one molecule, right? Which is the oxygen gaseous oxygen molecule. However, if you're looking at the oxygen element on the product side, you will see that oxygen element appear on both molecule of the product, right? Carbon dioxide and water. So the first thing that you need to avoid is don't start with oxygen. The reason for that is because oxygen appear in both molecule of the products. It's going to be too complicated to try to balance this, right? Which one you're going to add, right? So that's just going to be a little bit complicated. So avoid that. So avoid the element that appear in more than one molecule of the same side. Okay, so in this case I'm going to start with hydrogen then, because 4 here, 2 here, so I'm going to add 2 in order to make this to equal to 4. In order to balance the chemical equation, you are going to add the number of the element by using the coefficient. Okay, so the number in front of the molecule we call coefficient. Okay, do not or never ever change the subscript. Okay, because if you change the subscript, you are changing the identity of the molecule. Remember the joke that I always said, right? So a guy go to the bar, order water, right? His friend said, I would like order H2O, right? And then his friend said like, oh, I would like H2O too. And then he ended up drinking and died because H2O2 is not equal to H2O, right? Because if you change the number of the subscript, you are changing the identity of the molecule pretty much. Okay, so in this case, we don't want to change the subscript. What we want is we need the coefficient in front of that molecule. So when you write a coefficient, this coefficient imply that you are going to have to separate water molecule in the reaction. That's what these two mean. Okay, so it means that you are having two molecule of water. Okay, so that's what the coefficient mean, is represent the whole molecule. Okay, so if you do that, you will see that if you add 2 in front of water, you now would have 4 hydrogen total, right? How many oxygen then? Oxygen now is going to be 4 too, because you have 2 from here and you have 2 from water as well, right? Because if you think about this, you have 2 molecules of water. So total number of hydrogen would be 2, right? So 2 and then add 2 from here. So total would be 4. Okay. So according to this is already balanced, right? So actually not yet, because oxygen here is 4, but oxygen here is 2. So therefore you need 4, right, total. So you need to add 2 in front of the oxygen molecule. So total now oxygen would also be 4 as well. So we have equal number of carbon, equal number of hydrogen, equal number of oxygen. Therefore the mass on both sides, both reactant and the product, will come out to be equal. Okay, so this reaction is already balanced. So the general rules how to balance the equation is already summarized in page 129. Okay, so this is just a general guideline. Okay, so just use it as general guideline, because eventually you are going to be able to write the balanced chemical equation by practice. Without practicing, you will not be able to do the problem on the exam, and also you will not be able to finish it on time as well. Okay, so just use this as a general guideline and practice a lot, and you will get a hang of it eventually. Okay, so let's take a look at what type of problem that you are going to encounter on the exam, right? So pretty much it's going to be start with something that we learned before, right? We learn how to write chemical formula, right? From naming, we learn about how to name things. So that's going to be used in here, okay? So it will be used to incorporate how to write a chemical equation. For example, in this case, we are going to write a balanced chemical equation for each of the following reactions. So that means first, in order to write the correct chemical equation, you will need to know the correct chemical formula of each of those first, right? So that's what it pretty much tells us. Okay, so I'm going to start with 4a. Okay, so it says solid iron. Okay, so iron is an element, Fe, right? So we're going to start with that. And because it says solid, so I'm going to include the physical state as well, which is solid. React with would be plus psi, right? So because they both react with each other, they both add together, reacting with each other. Okay, so you are going to represent that by plus psi. And with oxygen gas, so it's O. But remember there is the list of the diatomic molecules that present in nature as like 2 atoms as 1 molecule, and oxygen is one of them. Okay, so if you recall, there would be what have no fear, right, of ice cold beer, right? So those are the element that present in nature as the atomic molecule. So whenever that you are seeing any of these gases, right, you need to know that they are going to come with the subscript 2. If it said react with fluorine gas, you need to know that you have to use F subscript 2. Same thing with the nitrogen gas, right? So this is oxygen gas, so that's why I use the subscript 2. And again, the physical state of this would be gas, right? So you need to represent that too. To form, okay, or to produce, or lead to, or to yield, right? So any of those is tell us that it's going to be separated by the arrow. Okay, so these react together is going to form what? Solid iron oxide. Okay, so iron is Fe, right? Oxide is oxygen. So we already know that this number 3 Roman numeral is indicate the charge of the iron. Therefore, I'm going to put iron 3 plus. And because this is metal, this is non-metal, therefore you are going to have to assign the non-metal charge as well. And oxygen is in group 6a or group 16. The charge of oxygen would be 2 minus. Therefore, to write proper chemical formula of ionic compound, you need to make sure that their charges need to be balanced. So in this case, you will need 2 of the iron per 3 of the oxygen. And of course, this is in solid, so you need to specify the state as well. Okay, so next thing is to balance. So you already know how to write each of those chemical formula. The next thing is to balance the chemical equation. We have 1 iron here, we have 2 iron here, we have 2 oxygen, we have 3 oxygen. So clearly they are not balanced, right? So it doesn't matter which one you start with, because oxygen appear in only 1 molecule on the reactant side, same as for iron as well. Same as for the product, right? Oxygen and iron is appear in only 1 molecule on the product side. So it doesn't matter which one you start with. So I'm going to start with iron, put 2 right here. Then I will go nowhere, right? Because if I start 2 iron, then the oxygen is not balanced yet. So that means I cannot start with iron in this case. Okay, so even though I can, but it doesn't lead us to anywhere, because at the end, if you balance iron equal to 2, then oxygen still not balanced. Okay, so that means in this case 2 will not work. Okay, the next one is, well, maybe look at the oxygen, right? Oxygen, 2 on this side, 3 on this side. The easiest way to look at this is to find the common denominator, right, between 2 and 3. So the common denominator would be 6, right? So to make them equal, you need to reach on both sides equal to 6 atoms of oxygen. Therefore, you will need 3 on this side, you will need 2 on this side, right? Because 3 times 2 equal to 6, right? The number of oxygen, because you have 3 times 2. This one right here, if you're looking at only oxygen, you have 2, right, times 3 equal to 6 as well. Therefore, in this case, you will need to add 4 in front of iron, right, because 2 times 2 is equal to 4 eventually. So this would be the balanced chemical equation for 4a. Okay, So I'm going to let you pause the video for a few minutes here, and I would like you to complete the problem 4B. Okay, so please do pause the video, because without doing so, you will not know how to do this yourself. Okay, so watching is really easy, but do it yourself is really difficult, right? So this is a good practice for you. Okay, pause the video now, complete 4B. Once you finish, resume the video again. All right, now let's check your answer with me. So first we will need to extract the chemical name, right, and write it as chemical formula, and pretty much put them together in terms of chemical equation. And then the last thing we're going to do is to balance the equation. Okay, so that would be the step that we're going to do. So aqueous hydrochloric acid. Okay, so the word acid is implied that you are going to start with the hydrogen. Okay, so because hydrogen have to come first for the acid. And hydrochloric, the word hydro imply that this chemical equation of the acid will not contain oxygen. Therefore, it's going to contain only the chloride ion, right? So you are going to add these two together, right? And then acid would be the aqueous, right? So it would be AQ. So that means the chemical formula of hydrochloric acid would be HCl and with the AQ. Okay, so aqueous, that's what is implied. React with, again, is going to be plus sign. Okay. Solid manganese for oxide. Okay, so what is the chemical symbol of manganese? Is Mn. Okay, not Mg. Do not confuse. What is this for telling you? For tell you that is the charge of the manganese, that is +4, right? For oxide or oxygen is in group 16 or group 6A. Therefore, the charge of oxygen would be 2-. Okay, so that means to make these two ions balance in a chemical formula, you will need 2 of the oxygen per 1 of the manganese, right? Because we have 4+, we have 2-, so you need 2 of oxygen. Therefore, the chemical formula of manganese would be MnO2. Okay, so again, it's in solid. Okay, so don't forget that solid. To form, okay, so to form is the separated by the arrow. Aqueous manganese 2 chloride. Again, so manganese is Mn, right? Roman numeral 2 right here specify the charge of the manganese. Okay, so chloride is Cl, right? So chlorine or chloride, chlorine is the neutral elemental atom. Chloride is once the chlorine like gain or lose electron, is become ions, right? So that means pretty much the word chloride would imply the ions of the chlorine. Okay, so what is the charge of chlorine then, or chloride in this case? Well, because chlorine is in group 7A or group 17, it most likely going to gain 1 electron, therefore the charge would be -1. So that means in this case the chemical formula of these two would be 2 of the chlorine per 1 of the manganese, right? So again, when you write the chemical equation, when you write chemical formula of the ionic compound, you need to start with the metal first, right? Followed by the non-metal. So in this case would be MnCl subscript 2. And it said aqueous, right? So that means you need to specify the charge as well. Oh, sorry, the physical state. Okay, and it's also form liquid water. Okay, so you need to know chemical formula of water, which is H2O. Okay, so liquid, right? So with the liquid. And chlorine gas. Remember, chlorine gas is one of the diatomic molecule, right? So have no fear of ice cold beer. So in this case, chlorine would be subscript 2 because it's present in nature as diatomic molecule. So it's in gas too, so it would be G. All right, so what should we do here? Okay, so the next thing is to look at what element should we avoid, right? So if you're looking at hydrogen, maybe we can start with that, right? Because only one hydrogen appear in only one molecule on this side. Same for this, right? You can also start with manganese as well, right? You can start with oxygen as well because oxygen appear on only one molecule, right? This one is appear in only one molecule. However, you should avoid chlorine because chlorine, if you're looking at product side, chlorine appear in 2 molecules of the same side. So that means if you start to balancing chlorine, it's going to be a little bit complicated. Okay, so don't start with chlorine. Okay, because appear in more than one molecule of the product side of one side, right? So it's just too complicated. So you can start with any of those, but which one that is going to lead to the productive balancing chemical equation then. So what I would do is I would avoid manganese because it's already 1-to-1. It's not going to lead you to anywhere, right? So in this case, what we can do is either start with like oxygen, right, or hydrogen. So in this case, I'm just going to choose hydrogen. Okay, so we have 2 hydrogen here. I need 2 hydrogen on this side, so I'm going to add 2 as a coefficient. If I do this, we already have 2 hydrogen. We already have 2 hydrogen. The next thing you are going to do, because you already add 2 on this in front of this molecule, therefore you are going to look at the next element within the molecule, so that way it's easier. Okay, so 2 chlorine, we have 2 chlorine, right? And this one have 4. Okay, so I can't use that yet because chlorine is the one that we don't want to start with, so I'm going to avoid that. Okay, so keep in mind we have chlorine now. So the next thing is, if I look at manganese, right, so manganese would be 1-to-1, so I can't do that, so I'm going to start with 2 oxygen. Okay, so let's see if that would work. If I have 2 oxygen here, I have only 1. Therefore, if I put 2 hydrogen in here, it would not work, right? Because it still requires 2 oxygen here. So that means in this case, this one is not going to work, because if you balancing these 2, then you are going to miss the oxygen, right? So in this case, I'm going to start with oxygen then. So I'm going to put 2 in here so that number of oxygen are the same. Okay, so 2 oxygen, 2 oxygen. And because I put 2 in front of water molecule, we have 2 oxygen, we have 2 oxygen on this side. Total number of hydrogen on this side would be 4, right? Because you look at the next element within the same molecule, right? You put 2 in water, you already balance the oxygen. The next thing is going to be the element within that molecule. So it would be hydrogen next, so it would be 4, right? So we have only 1 here, so I'm going to need to add 4 there. If you add 4 hydrogen here, okay, you are going to look at chlorine next, right? So we have 4 chlorine, right? 4 hydrogen, we have 4 chlorine. And how many chlorine on this side? We have 2 plus 2, that would be 4. So that means number of chlorine would be equal in this case, and number of manganese also equal as well. So this is the balanced chemical equation, because you have 2 oxygen, you have 4 hydrogen, okay, you have 4 chlorine, 2 plus 2 is 4, and then you have 1 manganese on each side. Okay, so this is already balanced. Okay, all right, so let's take a look at C. Okay, so I'm going to do the same thing. Okay, I'm going to walk you through. So this one is going to be there will be one more step that I'm going to add to, and I'm going to let you practice D. Okay, so let's take a look at 4C. Liquid hexane, okay, it's already giving you the chemical formula here, so C6H14. If there are a common name or a specific name for molecule, you don't need to memorize those. Okay, so I'm going to give you the chemical formula for those. Okay, so the thing that you will need to know is what we learned in the previous chapter section, right? So for example, how to name ionic compound and a binary molecular compound that we learned earlier. Okay, so this is liquid hexane. Okay, so I'm going to start with that. React with oxygen gas. Again, you need to know that oxygen is one of the diatomic molecules, so it would be O2. Okay, form carbon dioxide. Okay, what is carbon dioxide? Okay, so carbon would be C, right? Dioxide means you will need 2 oxygen. Okay, so it would be CO2, and it's gas. And also it's going to form water vapor too. So I'm going to add water vapor, which is gas, right? Now, what we are going to do is we will look at what we should avoid. Okay, so again, I'm going to avoid oxygen. The reason for that is because oxygen appear in more than one molecule on one side, right? So if you're looking at the product side, you see that oxygen appear in both molecule of the product. So it's just too complicated. So I'm going to avoid with oxygen. Okay, don't start with oxygen first. Start with something else. Okay. Now, can we start with carbon or hydrogen? Either way, right? So you should be able to start with that. Okay, so I'm going to start with, let's say carbon then, right? So we have 6 carbon. So I'm going to add 6 right here. Okay. We have 14 hydrogen. We have only 2 here. So I'm going to add 7, right? So 6 carbon, 14 hydrogen, 7 times 2 is 14. So we also have 14 hydrogen as well. But the number of oxygen, if you count the number of oxygen, right? So we have oxygen, okay, so 6 times 2, that's 12, okay. This side right here, we have 7 oxygen, right? Because 7 times 1 equal to 7. So add them together, this is going to come out equal to 19, okay. We have 19 oxygen, okay. We have only 2 on this side, right? So we have only 2 oxygen, okay. So that means in this case, how do we make 2 and 19 to be the same, right? Because they both have to be equal. And you will see that this is not an even number, so you can't just do it easily. So the best way to do is, well, because we want 19, right? So we can maybe have this as a fraction. Whatever you want, 19 is, you are going to divide by the 2 that you have. Because if you think about this, right, 2 multiplied by the number of the coefficient that we're going to put into here is going to give you equal to 19 eventually, right? So that's what we are going to do. So what I'm going to do is that, think about this, because I need 19 oxygen. Okay, so what we're going to do is I'm going to put 19 over 2. Or if you think about that, it would be, you can report as a fraction too, right? So 9.5, right? So, oh, sorry, decimal form, right? So this decimal form and this fractional form, they represent the same number. Okay, so pretty much if you think about this, right, if you multiply 9.5 by 2, right, so this is what we have, it's going to equal to 19. Same for this side as well, we just add all of those up, is equal to 19 as well. Okay, but we are not going to stop here, because in a balanced chemical equation, you should not have the fraction or decimal form in your chemical equation. So what you are going to do, there will be one extra step that you are going to do here, is to multiply the whole equation by 2. The reason for that is because we want to make this to a whole number, right? We want to make this fraction number to be a whole number. So you're going to buy everything by 2s in order to make this to be a whole number. If you do that, you are going to end up with 2 hexane, right, plus 19 oxygen, right, because 2 times 9.5 or 2 times 19 over 2 is equal to 19. And you are going to get 2 times 6 would be 12. You are going to get 2 times 7 would be 14 water. So this would be the chemical balanced chemical equation for this reaction. Okay, so again, it's going to have to be in the smallest ratio as well. Okay, so this is in the smallest ratio. You cannot get any lower than this. Okay, so if you are not sure, right, so before you can move on to the next, you can also check your answer as well. If you're looking at this, you can see that for carbon, right, for carbon, you would have 2 times 6 equal to 12, right, so that's come from 2 of this whole molecule. Each of this molecule has 6 carbon, right, so total carbon would be 12. For hydrogen, you are going to have 2 molecules of the hexane. Each hexane contain 14, right, so that would be 28 hydrogen. For oxygen, you have 19 of them, and each molecule of oxygen contains 2 atoms of oxygen. So therefore, in this case, the answer would come out to be 28, right? Oh, sorry, 38. Okay, sorry, 38. 2 times S is 18. So 2 times 1 is 2 and 3. Yeah, so it would be 38. Now you can also check on the other side too. Okay, so for the other side, you have carbon. You have carbon from carbon dioxide, 12 of them. Okay, and each carbon dioxide contain each carbon dioxide contain 1 carbon. So total would be 12. For hydrogen, right, you have 14 water. Each water contains 2 hydrogen, so total would be 28. For oxygen, right, you have 12 of the carbon dioxide. Okay, each carbon dioxide contains 2 oxygen. Okay, you're gonna add that, right? So you're gonna add that to 14 water, and each water contain. You will need to add this to 14 water. Each water contains 1 oxygen. Total would come out to be 38 also. Okay, so that means in this case, both side of equation is already balanced. So that means this is the correct answer. Okay, so you can also check that as well. All right, so the next thing is, I would like you to work on the last one, okay, by yourself. Okay, so I would like you to pause the video, complete 4D now, and then when you finish, resume the video again. All right, let's check your answer. Okay, so we're gonna start with gaseous ammonia. Okay, so this is a chemical formula of ammonia. It's in gas state, right? So don't forget that. React with oxygen again. Okay, so O2 gas to form nitrogen monoxide. Okay, so nitrogen would be what? N, right? Monoxide would be just indicated 1 oxygen. Okay, so this is gas too, and also is going to produce water vapor. Okay, so that would be the chemical formula. Oh, sorry, that would be how you set up the chemical equation. Okay, so the next thing is to balance the chemical equation. Okay, so which one should we avoid? Clearly, we should avoid oxygen, right? Don't start with oxygen because oxygen, again, appear in more than one molecule on the same site, right? So we're going to avoid that. Okay, so should I start with nitrogen then? The answer is no either, because if you start with nitrogen, it's not productive, right? It doesn't go anywhere because it's already one-to-one. So that means in this case, it's forced us to start with hydrogen, right? So we have 3 hydrogen, we have 2 hydrogen. So find the common denominator. So that would be 6. So that means 3, to make a 6, you need 2 of that, right? So you're going to put 2 here, you're going to put 3 here. So therefore, the number of hydrogen now would be 6, right? So 2 times 3 equal to 6, 3 times 2 equal to 6, okay? The next thing, looking at nitrogen, right? We have 2 nitrogen here. We have only 1. So what I'm going to need is I need 2 nitrogen on this side. Okay. The last thing is going to be oxygen now, because you already balanced hydrogen. You already balanced nitrogen. The next thing would be oxygen. Okay. So how many oxygen total? We have 2 oxygen on this side, right? So we have 2 oxygen from that. We have 2, right? So this one come equal to 2 plus 3, right? Plus 3, that's equal to 5. So again, these are not the same, right? 2 and 5 are not the same. So to make these to equal to 5, you will need what? 2.5, right? Because 2.5 times 2 equal to 5, right? So that means the coefficient that go in front of this need to be 2.5, right? Or 5 over 2, right? That go in front of this, because 2.5 multiplied by 2 is going to equal to 5. So that's what I'm going to do. Okay, so again, if you start like this, then you will see that it should not be in the fractional form or decimal form. We need to make this to be a whole number. So what can we do? Well, 2.5 multiplied by what to give us the whole number? And the answer is going to be 2, right? So you're going to multiply this by 2. Okay, so when you multiply this by 2 to get a whole number, you need to multiply the whole equation. Because if you think about this is already balanced, but it's just not in the whole number, right? So all of this already balanced, right? So you have 5 oxygen, right? So you also have 5 oxygen. You have 2 nitrogen, you have 2 nitrogen, you have 6 hydrogen, you have 6 hydrogen. It's already balanced, but it's just not in a whole number. So in order to make a whole number, you will need to multiply the same coefficient throughout the whole equation. So in this case, I'm going to multiply by 2, because 2 multiplied by 2.5 or 5 over 2 is going to give you the whole number. If you do that, the answer would come out to be 4 ammonia, right? So you multiply this in there. 5 oxygen lead to 4 nitrogen monoxide and lead to 6 water. So again, if you are not sure, you can count the number of nitrogen as well. We have 4 nitrogen, 4 nitrogen. We have 4 times 3 is 12. We have 12 hydrogen. We have 12 hydrogen. 6 times 2 is 12, right? 5 times 2 is 10. We have 10 oxygen. Here we have 4 oxygen plus 6 oxygen equal to 10 as well. So that means this chemical equation is already balanced. Okay. So again, this is in the smallest ratio to 4 to 5 to 4 to 6. You cannot make any smaller ratio than this, right, as a whole number. So that means this is correct answer. Okay. So the next part of this, or the last part of this lecture section, is that if I give you the equation that is already written to you, like pre-written to you for the chemical formula, you will also need to be able to balance the chemical equation as well. Okay, so we are going to look at 5a. So the first expectation would be giving you the name, right? Then you write out the chemical formula, and then you put into the chemical equation, and then you balance the chemical equation. So this one, I already give you the chemical formula. The only thing you need to do is balance chemical equation for this, right? So in this, there is some tip for this that I would like to go over, so that way you understand it better. So let's take a look at 5a together. 5a, if you're looking at 5a, you probably notice the polyatomic ions, and that is nitrate, right? NO3. Okay, so nitrate is NO3. Whenever that you see nitrate or any polyatomic ions that appear on both sides of equations, okay, so for example, in this case, remember, we separate this by the arrow. So nitrate appear on the reactant side, nitrate also appear in the product side. So in this case, nitrate, which is the polyatomic ions, they are appear in both sides of equation, what you are going to do in order to avoid complication is to keep them together as a bundle. Okay, you do not break them. Okay, keep nitrate as a whole bundle. You're gonna treat nitrate as a whole thing. Okay, so as a whole group. So if you're looking at the group of nitrate on the reactant side, okay, you will see that there are 3 of them. If you are looking at group of nitrate on the product side, there are only just 1, right? Because nitrate is NO3. Remember, so this is just 1. This nitrate right here, NO3, but you have subscript 3, so therefore it's 3. So you're going to treat them as a bundle. You will not need to separate them. If you break them apart, it's going to take you forever. Okay, so that's when you will run out of time when you do the exam. Okay, so I do not recommend that for you to do that. Okay, so these are the tips that you will need to understand. Okay, so what should we do then? Well, because we have 3 nitrate here, so I'm going to add 3 in front of this because this one, then we are going to have 3 nitrate, right? Because 3 as a coefficient imply that we're going to have sodium nitrate, 3 of them, which is exactly what we want, right? We want 3 nitrate, 1, 2, 3. We want that 3. So therefore we need to add 3 right there. If you add 3 here, what you are doing is you're going to look at the next element, which is sodium. If I look at sodium, there are 3, right? According to what we just add here. But on this side, we have only 2 sodium. So that means in this case, it will not work because 3 sodium and 2 sodium, there is you have to find a common denominator in this case, right? So in this case, I'm going to not start with the nitrate. I'm going to start with chromium instead. Okay, so chromium, there are 2 in here. So there is 1, so I'm going to add 2. So we have 2 chromium. And if you have 2 of these, you are going to end up with 6 nitrate, right? So pretty much this thing right here is implied that you have chromium nitrate, 2 of them. And because we have 2 of the chromium nitrate, therefore the total number of nitrate would come out to be 6, right? Because this is subscript 3 right here. So that means in this case we have 2 chromium. We have 2 chromium. We would have 6 nitrate. We have only 1 nitrate here. Therefore, I need number 6 in front of it. Okay, so now we have 2 chromium, 6 nitrate, right? 6 nitrate. Remember, you are going to multiply this whole thing together, right? To get, so that's 6. So we have 3 of these multiplied by 2. That's 6 as well. So that means the next thing is to go look at sodium, right? Now sodium has 6. We have only 2. So in order to make it 6, you will need 3 in front of that. Okay. So what next then? Well, if you add 3 in front of this, you are going to make the number of sulfur in the reactant side to equal to 3. If you check that on the product, oh, sulfur also is 3 as well. So that means in this case, this reaction is already balanced. When there is number 1 in front of this, if you just need 1, you don't need to actually write that 1 out. You can ignore it, okay? But don't write 0 because 0 implies that you don't need any of them at all. Just either write 1 or omit the number. Okay, so you can do one of those. Okay, so if you leave it like this, it just means that it's already, we need 1 of that. Okay, so just don't write 0. Okay, so if it's 0, then it just means that you don't need that at all, which is incorrect. Okay, so either leave it alone or just write number 1 in front of it. Okay, so those are the 2 options. So now let's take a look at C. Okay, so C, can we treat C like what we did with the 5A? The answer is, okay, so we need to find out the polyatomic ion first, right? So clearly we see phosphate, right? So PO4 is the phosphate ion. So we see phosphate on this side. But do we see phosphate on the other side, right? Remember, we separate by the arrow. The other side, there is no phosphate. P4 or 10 is not the same as PO4. So that means in this case, these 2 right here are not the same polyatomic ions. This is not polyatomic ions at all. It's the molecular compound, right? So that means in this case, you cannot treat it as 5A that we did earlier. Okay, so in this case, you will need to break it down. Okay, because you don't have phosphate on both sides that you can treat them as a bundle, right? So you have just 1 of them. So in this case, you will need to break it down. In order to break it down is, what I mean by that is to just look at 1 element at a time. That's what I mean. Okay, so for example, in this case, you are going to avoid oxygen again, right? Because if you're looking at oxygen, oxygen appear in more than one molecule of the same site, right? So in this case, oxygen appear in 2 molecules of the reactant site, so we're gonna avoid that. Okay, do something else but not oxygen. Okay, so I'm gonna start with phosphorus then, because we have 4 phosphorus here. You're gonna add 4 in front of it. Okay, so now you're gonna have 4 phosphorus as well. Okay, so 4 phosphorus, 4 phosphorus. If you add 4 in front of this, it's going to force hydrogen to be 4 times 3. That's equal to 12, right? We have only 2 here, so you need 6 of them in front of it. So again, how did I get how did I get 12 hydrogen? So this again come from when you rewrite H3PO4 4 times, right? That's what the number 4 as a coefficient represent is represented. You have 4 molecule of this, right? You can write out, and if you count them, right, 3 plus 3 plus 3 plus 3 is come out equal to 12 hydrogen. Okay, so same thing for this as well, right? If you rewrite this 6 times, right, each of them contain 2, therefore it's going to come out equal to 12 hydrogen. Okay, so that's what it means. So next is looking at oxygen, right? So what do we have here? Okay, so we have 4 phosphorus, we have 12 hydrogen, we have 12 hydrogen. Okay, we have 6 oxygen, right? Because each hydrogen contain 1, we have 6 of them, so 6 oxygen plus 10. So that means in this case you will have 6 plus 10 would be 16. Okay, so in this case, this part right here, this oxygen plus this oxygen, 10 plus 6 come out equal to 16. For this side, oxygen, 4 times 4, right? You have 4, and each of those contain 4 oxygen. 4 times 4 equal to 16 as well. Therefore, in this case, this is already balanced. Okay, so it would be 1 to 6 to 4. Okay. All right. So what I'm going to let you do next is going to be the rest of this. Okay, so I'm going to give you a few minutes here to complete 5E and 5B and also 5D as well. Okay, so let's pause the video now and start working on those. Okay, and then resume the video to check your answer again. All right, let's check your answer together with 5E. Okay, so 5E, again, so if you're looking at this chemical formula, you probably recognize the polyatomic ions again, right? So nitrate, phosphate, okay? And both of them appear on both sides of equation, right? Remember, we're separating by that arrow right there. So they both appear on both sides of equation. Therefore, in this case, we're going to treat them as a bundle because you don't want to break them. It's too complicated. You're going to treat them as a whole group. This group gonna stay the same, this group gonna stay the same, right? So this group gonna stay the same, this group gonna stay the same. We're gonna count the number of those groups, okay? So if you do this correctly, you are going to have the, so let's see, right? So we have phosphate here. I'm gonna start with phosphate there. Then we will have 6 sodium. I put 6 here. Okay, so that's gonna put nitrate to be 6 nitrate. So we need 3 here because 3 times 2 would equal to 6 nitrate. That's going to put barium to be 3, right? So we already have 3. So this is already balanced chemical equation. Okay, so check your answer. Now let's take a look at 5B. Okay, so if you look at 5B, there are only 2 elements, right? Hydrogen and nitrogen. The one that we need to avoid would be the nitrogen. Do not start with nitrogen first. The reason for that is because nitrogen appear in more than one molecule of the same side of the equation, right? So in the product side, you see nitrogen appear on both. Okay, so we're gonna avoid that. So we're gonna look at hydrogen in this case first. We have 4 hydrogen, we have only 3. So the common denominator between 4 and 3 would be 12. So therefore, you will need to make this to be 12, you need to multiply this by 3. To make this to be 12, you need to multiply this by 4, right? So that means in this case, you need 3 and 4 for the coefficient for those. If you do this, you are going to put the number of nitrogen on the reactant side, right? So we are going to separate by that. Okay, so the reactant side now would have 2 times 3 would equal to 6. We have 6 nitrogen. Okay, we have 4 nitrogen, right, from this, plus 2 nitrogen from here. That's equal to 6 as well. So that means this chemical equation is already balanced. Okay, so check your answer. All right, last one is D. Okay, so D, which one should we avoid? Okay, so if you're looking at this, the one that we should avoid would be fluorine, right? Because fluorine appear in more than one molecule of the same site, right? Again, so this we separate by the arrow. This site right here contain fluorine that appear in both molecules, so we're gonna avoid that. Okay, so start with something else, but not fluorine. Okay, so you can either start with hydrogen and see where it lead you to, or you can start with so if you start with calcium, it will not lead you to anywhere, right? Because already 1-to-1. If you start with silicon, same thing, it's 1-to-1. Okay. If you start with hydrogen, that might lead you to something, right? Or oxygen. So I'm gonna start with those two. Okay. So we have 3 oxygen here. We have just 1. So if I put 3 right here, let's see what happened, right? So if I put 3 here, it's going to so oxygen 3. Oxygen here would be 3. Hydrogen now would be 6, right? We have only 1 hydrogen here, so I'm going to add 6 in front of it. Okay, so 6 hydrogen, 6 hydrogen. It's going to make fluorine 2 equal to 6 as well. Now fluorine, right? We have 4 plus 2 from here is also equal to 6. This is going to be the correct chemical equation. Okay, so it would be 1 to 6 to 1 to 1 to 3. Okay. This is just a general rule, okay, so that you can go over. And again, practice, practice, practice. That's the key for this section. And once you finish watching this video, please start working on the homework soon. Okay, so it's gonna give you exposed to more type of equations